Prashant voor ons een talk gaan geven. Bij ons al meerdere keren talk gegeven, dat is een groot succes geweest. Dus
Yeah? Okay, cool. All set? All right. Hi, everyone. Thank you so much for coming. I was not so sure after seeing the weather. Like, first of all, it was summer, so I was dressed completely like summer. Then it became winter, and now it's summer again. So it's all good. It's all good. Good to have you all here. I'm Prashant, and just gotta be honest, like, I realized later that the title of the talk and meetup page said, like, Vue.js saved my day, which is kind of radical. It was not meant like that. It was supposed to be 6 times Vue.js saved my day, which is a little bit calm down, I guess. It was, otherwise it seems like Vue.js is the solution to all my problems or something like that. It's not like that. What I'm here to do is, so I'm using Vue.js in a couple of projects of mine, and there were 6 times where I ran into issues, and I found out that Vue.js had a nice solution out of the box, right? So those 6 times I documented it, those times, and that's what I'm here to talk about, right? I'm going to show you what Vue did, how Vue helped me those 6 times. And I'm not here to cause any kind of framework wars or something. I'm not here to say like, hey, next project, Vue.js, because that's definitely better. No, not here to do that. It's just sharing my own experience. For the people who are on Vue already, like how many people are doing Vue? Yeah, awesome. So probably you guys already are aware of many things that I'm going to be talking about today. But I hope that the key takeaway will be like, I am going to touch upon a little bit about the internals of Vue, on how Vue does things. And I'm going to share with you guys like some plugins and tools that I like to use when I'm working in Vue projects. Hopefully that will be the takeaway for you guys. And for the rest of you people who are not in Vue, maybe you can, the key takeaway can be like you can try to incorporate these design patterns and solutions that Vue have in your own ecosystem or something like that, right? So it's just sharing experience here. Got a lot of ground to cover, so I'm going to jump right into it. My name is Prashant Palikhe. Just a little bit of introduction of myself. You can find me on Twitter over here, at Prashant Palikhe, my full name. I'm a developer at front-end consultancy called Frontman in Utrecht. And I'm currently, well, I'm currently busy with this project on Vue called Talent Excellence, but that doesn't mean anything to you guys, I guess. So I'm just going to go right into the topic. And I'm going to start with Vue's reactivity system. So what is reactivity system, right? So let's get that clear first. So reactivity system is like most of these tools and libraries that we have right now, like Vue, React, or whatnot. In their core, they're trying to solve the exact same issue, right? They're trying to solve the automatic update. Whenever the state changes in your application, that the Vue gets automatically updated, right? That's the core problem that they're trying to solve, and they try to do it in their own way. And besides that, they have a lot of other things going on, but in their very core, that's the main thing that they're trying to help us developers with. And that's the reactivity system. In this example, we got the state of the application over here, name John Doe, position singer, and later, let's say the state changes, and the reactivity system of your tool is going to automatically update the DOM to represent the latest state of things, right? Because back in the days, we used to do things a little bit differently. We were not creating like really JavaScript-heavy applications, so jQuery is actually just fine for the kind of applications we were building back then, but it didn't scale well as we started doing more and more JavaScript on the front end, right? We started writing actual full-blown applications, lots of business logic. We started putting them on the front end, but we were still trying to, you know, like query the DOM, find the element, change the class, hide them, animate them and all that stuff. Very imperative. And when you try to get into a project, like a large-scale project written this way, you know, it's kind of nightmare to wrap your head around what's going on, right? We've all been through that. So that's why like these newer platforms, newer solutions give us this more declarative way to define the relationship between the state and the DOM. In this case, this is Vue template example. So here we got users array, and we're looping through the users array, and we're just showing the username and the followers count for the user. And this is very declarative, and when you click on it, it's apparently going to the user. So there's not a lot of code you need to you know, interpret and understand. It kind of tells you what the code is doing. It's not telling you how the code is doing that, but more like what the code is doing. That's the beauty of the declarativeness, right? And that's what these new tools are trying to do. And when later, for example, users array changes, this Vue is going to be automatically updated. And that's the reactivity system. And I want you to understand the magic behind Vue's reactivity system. Like, how is Vue actually doing all this? And I found out some interesting thing. So let's start with a simple Vue component. In Vue component, you write this thing called single file component, which is a .vue file. And within that single file component, you can write in templates. These are, in React terms, like the JSX part, right? And you have your component business logic, which you write within script. And you can also have styles if you want for the component. This is a very simple component. What we're doing here is just displays the name. Where does the name come from? It's the state of this component, named John Doe, right? It just simply displays this. So when you write single file components like this, this is something that the browsers don't know how to interpret by its own. You know, this template tags and like this, and all the bindings. This is something that the browsers don't know how to execute. So when you build a Vue application like this, during build time, using Webpack, using a Webpack loader called Vue Loader, Vue compiles this component down into something that looks like this. The only difference here is that template got converted into what we call render functions. Render functions, the H is an alias for create element, by the way. So these render functions are basically instructions for Vue on how and what to create for this component, right? Here we are telling Vue, like, hey, Vue, you got to create a div element, and its child is just going to be name that is coming from the state, right? So that's what happens. This is the code that actually gets executed in the browser. When this component's render function gets invoked in the browser, what it returns as a result of this invocation is a simple JavaScript object. That is a representation of the DOM element that Vue is going to create later. And this is what we call virtual node. It's not an actual DOM node. It's just a simple, cheap JavaScript representation of that node. It's sort of like a blueprint for Vue to create actual DOM node later. And that's exactly what Vue does. Later on, it uses this blueprint, virtual DOM information, to actually create the real DOM node, and it shows that in the browser. Now imagine later the state changes from John Doe to Richard Rowe, right? And somehow, let's just say somehow Vue was able to rerun this render function again, right? Now what happens? It's going to return a new virtual node, the one where the children is Richard Rowe instead of John Doe. Now what Vue does, it's going to compare the new virtual DOM with the old virtual DOM. It's going to do the diffing and find the minimum amount of change that actually needs to be applied to the DOM. And after that change is found, it's going to update the DOM. This gives us this nice virtual DOM. This virtual DOM pipeline is a nice way to efficiently update the real DOM, right? So that only the minimum amount of change is actually applied to the real DOM. But the thing here is, how does Vue know how to run this render function of the component again when the state changes? That's the magic, right? So the way it works is this component, the same component as we saw before, when this component is instantiated, because what we see here is just a JavaScript object, right? This is what we call component definition object. It just defines the component, tells what the component should do, how it's going to look like, but it's not actual instance. Vue uses this information to create an instance of the component. And when it does that, when it creates the instance of the component, it's going to loop through all the state properties. State properties are everything that goes in data, but also the props that come in from the parent components, right? It's going to loop through all those properties, in this case, name in this object, and it's going to redefine those properties using object.define property API. So object.define property, using this API, you can basically reconfigure, redefine any property in an object, right? You can make it non-writable, so people cannot assign to it again. You can make it non-enumerable, so you cannot loop through the object and find that property. In this case, Vue simply, like walks through this object, finds the name property, and is going to redefine that name property from the state using getters and setters. What does this do? Basically, whenever somebody tries to access this.name later, it's going to invoke this getter, right? And when somebody tries to assign a new value to this.data.name, it's going to call this setter. Now Vue has hooks to do something whenever the state is accessed and the state is changed, right? And that's what the rest of the reactivity system is built on, basically. So when this component's render function is first invoked for the first time, we're going to access this.name. That means that this getter is going to be called. So Vue is going to be like, okay, hold on. So this component is dependent on this.name. I'm going to go ahead and remember that relationship because I may need it later, right? So Vue is going to go ahead and remember the relationship between name, that state, and that component. And later, let's say, the component state changes from John Doe to Richard Rowe, and the setter gets called. And Vue is going to be like, oh, I know which component was dependent on this name property. So I'm going to go ahead and call the render function for that component, right? And that's what Vue does. It recalls the render function, and this time this.name has changed, and the rest is basically the same virtual DOM pipeline that we saw in the previous slide. It's going to return a new virtual node. Vue is going to do the diffing algorithm on it, and it's going to update the actual DOM with a new name. So that completes the reactivity system of Vue. And the main takeaway here is Vue is able to maintain this relationship, one-on-one relationship between every state you have in your application and every component that is dependent on that state. And that basically removes a whole category of performance optimization responsibility from my hands as a developer, right? For example, in React world, we would have to use should component updates so that we don't over-render the child subcomponent tree. Or you can use like, React pure components or something like that to prevent over-rendering. Vue doesn't have that problem with this kind of approach. Why? Because Vue knows exactly which component to re-render when a state changes. So no matter how big your application state tree, no matter how big your application component tree, there's exact one-on-one mapping between the state and the component, and Vue will never over-render. So this is really beautiful implementation from Vue side that I really, really enjoyed. And now that we have this information of how Vue is doing things under the hood, there are even more performance opportunities over here. So we basically learned that Vue is gonna walk through this data property and convert all of these properties into reactive getters and setters, right? So if this is a simple primitive here, a string, but this could be another object that contains nested objects, right? It could be an immense data structure. Vue is going to loop through all of those and convert each of them into reactive getters and setters. Everything happening in the main thread of your browser, everything taking CPU cycles. So that could, like many times when we're showing, when we are showing stuff on the application, it can be read-only, right? Imagine a product page. You're building e-commerce website, and you have a product page. You get the product's data from the API, and you show them, and for the rest of the lifecycle of the application, that data probably won't change. It's read-only. You just got to display it once, and then you're all set. But still, Vue is going to loop through the entire product object and try to make them reactive, right? So we could save some time. How can we do that? If you look into Vue's source code, I'm not sure if you guys can read properly here. This is the part of the Vue source code where it's converting those state properties into reactive getters and setters. And there's this one really interesting line. Before doing all this reactivity setup, it's going to check if that property is actually configurable, right? Configurable, and we can make any property in Vue, in an object, non-configurable using object.freeze, just the JavaScript API, right? So imagine you have a component like this, where we start with a product, null, and then we get the API data from some random API, we get the product, and we set that data over here, and when setting that, make sure you freeze that object, right? When you freeze that object, and Vue tries to make it reactive, Vue is going to be like, oh, turns out it's actually not configurable, so I'm just going to bail out of this whole reactivity setup, and just forget about that, right? So that's a way to optimize, like your data is probably not going to change in the Vue application, then let's not have Vue do all that work during runtime, right? That's a way to do it. Nice little trick that I use all the time. Why do I use it all the time? Even though there may be like small performance optimization, it may differ depending on how big your data object is. For example, if you're working with Google Maps, markers and stuff, there's tons of data. You don't want reactive. That will save you a lot of time. But sometimes it may be not so much time. But the investment itself is so little that I try to use it almost all the time. That's that. The next thing is, if you're curious about how your component is rendering, if it's taking a long time to initiate or render or update, then you can, just like a quick tip over here, you can set this flag to true, Vue config performance, and then when you go to Chrome DevTools and profile your application, in the performance panel, in the user timing section in the performance panel, you will see all this data about how Vue is rendering the component, how long it took to initiate the component, to render it for the first time, and how long it took to update it. So you can have all this data nicely in the performance panel for you to check out. And I usually set it to things like this so that I don't have all the performance marks in production setup, but on development setup, I have these marks available, right? So that's the first thing that I wanted to share. The second thing, after this sip of water. So next thing is first-class support for code splitting. So what is code splitting? Let's take a journey real quick. So back in the day, we used to ship our code like this, right? We're writing small JavaScript applications. We may have like our application code and another plugin, another library or something like that. And it was pretty small, so we would just like put them in the HTML just like this and ship the code. All good. Works great. But then we started using more and more plugins and more libraries and stuff. So then we quickly noticed that it's actually not so great for performance because all of these are separate network requests, right? So we are incurring like lots of network calls, and that can become the performance bottleneck. So we started concatenating these scripts, basically placing one on top of the other. I guess we all went through the same journey, right? And we even called this all.js, I think. Like everyone used to call it all.js. So we started shipping code like this, right? Concatenated scripts, no big deal. But then this guy came around. Anybody knows who this guy is? So this guy, go ahead, give it a shot. Yeah, that's right. Yeah, Ryan Dahl, the inventor of Node.js, indeed, in 2009 JSConf, right? So he came around and he changed the JavaScript world by introducing Node.js. Well, there were many cool stuff from Node.js, but one of the things that was really great was we could actually use real modules in JavaScript land on the server side, right? No more ifs and no more reveal module patterns, actual modules. What did the modules allow us to do? It allowed us to have like our own private variables within the module and have a nice public API. And most importantly, it allowed us to use third-party modules. And that resulted in like, like a burst of libraries and the creation of a rich ecosystem, which we call NPM registry nowadays, right? So that happened after Node. So we wanted to use this kind of module system on the front end as well. So tools like this came into picture. Another guess on what this tool is or who've used it? Yeah. Yeah, absolutely. So we try to organize like this quiz, front-end quiz every now and then from called Frontmania meetup. You should go there. I think you'll do good. Like, that's good. 2 of them, 2 out of 2, Browserify. So we started using these kind of tools. What does it do? So Browserify would, like inspect your code, go through your code, find out all the dependencies from your code, and then convert them or create one giant bundle that kind of looked like this, that included all your dependencies. And since browsers don't understand require and module exports by default, it would also convert that code into something else that all the browsers could understand, right? It would create this bundle.js for us. So we started shipping bundle.js using tools like Browserify. But it was not just CommonJS. So what is CommonJS? Whenever you're using Node and you're doing require and module exports, that's the CommonJS format, right? But it was not just CommonJS that was available as module system on JavaScript world. We also had ES6 modules. ECMAScript came about with its own module system where we can do just like imports and exports. But we also had like AMDs going around, so some people might have used it over here. So we had lots of different module systems, and to cater to all these different kinds of module system, tools like Browserify evolved into something like Webpack. So Webpack is and Parcel as well, right? Webpack and Parcel, they don't care about what kind of module system you're using. They're just going to create the same thing, dependency tree, and create one giant bundle for you guys, right? So we continued shipping bundle.js using Webpack. And then we realized, hey, actually, like bundle.js was containing all the third-party library and the framework as well, including together with our application code. And that's not performant because if we add like one little semicolon in our application code, that would invalidate the cache entire cache for the whole JavaScript bundle on the client side, and the browser has to re-download everything all over again, right? So we started using like split chunks plugin on Webpack to, like split this into bundle our application code and then vendor.js. A little improvement, but still not quite there. We're still shipping all our application code as one JavaScript, right? So it could be better. Why not just, like, for example, I went to github.com, I went to github.com homepage, and if you go to Chrome DevTools and hit Command-Shift-B, then you will see this nice command menu and type in coverage in there. That will lead you to this coverage panel. And this coverage panel is going to give you real-time overview of how much of your code is actually being used, JavaScript and CSS, right? So I checked this out on GitHub just purely for experiment, and turns out on GitHub's homepage, like 96% of JavaScript is not used. 99% of CSS is actually not used on the homepage, right? And most of us are doing this exact same thing. We're just shipping all our code as one bundle.js, and it's like, oh, great, everything works, right? So we could definitely do this better. As in, like, why not just load the code that is only necessary right now to run the current route that the user is in, right? That would be the most efficient. To help us out with that, dynamic import came into picture. So what is dynamic import? Imagine you have an application like this. Like, is this readable, by the way? It's a little bit too late to ask, but I'm just asking. Like, index.js, like, let's imagine that that's your application, and it has two modules, module 1 and module 2, right? And module 2 is necessary for the first paint of your application, so you need it right away. So how are you going to use it? You're just going to statically import it. Import module 1 from module 1, right? And then you're going to use it. When you build this application with Webpack, what it does is going to create one bundle.js, and that bundle.js comprises of index.js and module 1.js, right? So imagine that module 2 was needed only after some user interaction, like a click of a button or something like that. Only then you need the module 2. So it doesn't make sense to send the module 2 already as the part of the first bundle.js, right? We want to download it only after the button is clicked. So that's exactly what dynamic import allows us to do. Instead of statically importing using this formation, you use import as a method, and then you tell, like, hey, I want to download this module too, only when the button is clicked. And when Webpack runs into code like that, it's going to do something a little bit different. Instead of creating one bundle, it's going to create two bundles. The bundle.js is the same as before. It's still comprised of index.js and module 1. But there is a new bundle called one.bundle.js, which only contains module 2. Now, with using dynamic imports, this is, by the way, it's on stage 3 of TC39 process, so it's standard-based. So using dynamic imports, you can construct your application as the user interacts with the application and navigates through your application, right? Like, it's great for a time to first byte because there is a lot less JavaScript to parse, execute, and all that. So I wanted to make this happen in my application. And to me, it seemed logical to start up with routes, right? I had a route like this in my Vue application. So this is what the route definition. I had the main route, the most important one, the entry point. And I had another route, which I was importing like this. So I wanted to lazy load this route. Why load it already in the main page when user may never end up in this route, right? So it turns out in Vue, to make this lazy loadable, all you got to do is convert this import statement, static import statement, into a function that uses dynamic import, and you're all set. Vue does everything in the back and behind the scenes, so you can just, nothing else needs to be changed. Now this other route is lazy loaded, right? So if you haven't already done lazy loading of your routes in your Vue application, like, please let this be the first thing that you do when you go home and you're back on the Vue project. It's like, it's just this that's going to make your routes lazy loadable, but not just on routes. So I'm using this in models, for example. Models are something hidden from the user, and only after a user does something, the model gets shown. And I have something like advanced form component in there that has a lot of business logic and JavaScript in there. So why show it? Why download it when it's not necessary, until it's necessary? So same thing over here. Convert this static import into dynamic import, and you're all set. The reason that this works is because Vue can consume either the component definition object that we saw earlier, like something like this kind of object, or it can consume a promise to that kind of object, right? It works with both of those. So that's why, like, we use a function that returns dynamic import. Dynamic import returns a promise That's why all of this just works seamlessly. So making your routes lazy loadable is just a matter of changing this small route definitions and the component imports in your source code. So highly recommended to do this. But when we were doing this kind of thing, right, I lazy loaded the other route. So we improved the first page because there is no JavaScript to download and parse and execute. But we kind of deferred it until the point when the user actually ends up in the other route, right? So that route may be a little bit slower now because we downloaded only then. Can we make that better? Especially if you know that, hey, there's a high chance that the users are going to end up in this route. Maybe we can prefetch it. And that you can easily do using Webpack's magic comments or inline directives. So you tell Webpack, like, hey, Webpack, make sure you give the instruction to the browser to prefetch it. So when Webpack sees stuff like this, and when it builds the application, it will add this one line of code in the resulting HTML, right? So what we do here is we're telling the browser, like, hey, browser, when you're done doing your work for this page, when it's all done, and you're just sitting there being idle, make yourself useful and prefetch this JavaScript file in the background, so that later when we need it, it's already there in the HTTP cache. That's what it does, right? So later, when we actually end up to the other route, that bundle is nicely warmed up in the browser's cache. So that speeds up the initial page and also the later visits, right? So depending on how you see what the critical paths of your application are, you can sort of prefetch those routes already. What I like to do, usually I go with this plugin called Vue Router Prefetch. What it does is it's a little bit smarter. What it does is it observes, it checks for all these links that are coming into the viewport, the Vue router links, right? And as soon as the router links come into the viewport, if the user's network condition is good enough, it's going to go ahead and download that and save it in the cache. So I have a quick demo over here. So I have a page 1, and I scroll down, and page 2 becomes available, and it downloaded it at the bottom, right? So the page 2 JavaScript is already downloaded, and when I go to page 2, nothing else happens. So it's basically like if the user is in a good network condition, make sure you make use of it and pre-cache everything. So everything as a user navigates through the application is nice and fast. So that's the second thing I wanted to share with you guys about Vue. Oops. Third thing. Third thing is about modern code for modern browsers. So JavaScript language evolved, right? We have these nice new features. It's evolving in a really nice pace. We have classes and async await. But the browsers are not all updated in the same pace, right? That's why we have to use tools like Babel, I don't know how it's pronounced. Let's go with Babel. So we have tools like Babel, which which consumes the modern code and spits out code that can be run in any browsers, right? But the thing with this transpiled code is it's kind of chunky. If you have a class like this with a method walk, super nice and tiny, it ends up with something like this. So this is the transpiled code. And if you're not using Babel environment plugin or Babel runtime environment plugin, this happens in every module that you have. Not good, right? All these chunks. If you have async await, nice and tiny, it becomes something like this. And it's not only just a lot of code, but when you're trying to debug this thing in production, the source maps, I oftentimes find it not working really well, and I'm just putting breakpoints in 100 different places and hoping that it goes in the right place. It's not the ideal developer experience, and the worst thing is the users probably don't even need all this code, right? Your users are probably in the browsers that support all these new ECMAScript features by default, without the need for transpilation. So is there a way to ship modern code to modern browsers? How do you even do that? Can you feature detect availability of the class syntax and async await? Probably not, right? Because if you try to feature detect it, then you already have wrong syntax, and you'll get on-caught syntax error kind of message, right? If it's something like promises or fetch web APIs, then you can feature detect them and you can shim them, but not for syntaxes. It's very difficult. So what's the way to actually make sure that the modern browsers get modern code? There's this nice little workaround. script type module. That's the difference here. Like, for the rest, is the same as what we all see all the time, script that loads JavaScript. Script type module is created to load ECMAScript modules directly from the browser. So you can just do like imports and exports directly on the browser, right? And for those scripts, you use script type module. But script type module is able to load our regular, good old non-module JavaScript just fine. The good thing here, though, is all the browsers that support script type module supports all the ECMAScript 2015 features. So we have classes, arrow functions, fetch APIs, promises, and all, maps and sets and all that without the need to use a polyfill. So what you can do then is you can create two bundles. One modern bundle that you ship using script type equals module, and another script no module, and there you ship the old bundle with all the transpile code. Why does this work? Because older browsers, they don't understand type module, so they're going to ignore it. So they're just going to download bundle, the old bundle, right? And the modern browsers are like, hey, module, I'm going to download the modern build. Hey, no module, so I'm going to ignore it. So that's the reason why it works, like super hacky workaround or whatever. But it's a pretty cool trick. That's the way to ship modern code to modern browsers without doing user agent sniffing or something, especially when you don't have server and you're doing single page applications, then you don't have any other way to do it, right? So that's a nice little trick. So I wanted to implement this in the application. And turns out on Vue, oh, by the way, this is the browser list that you can configure in Babel to generate the modern build. All the browsers that support type equals module. Chrome, Safari, iOS, Firefox, Edge, they're all there. So that's really cool. So I wanted to implement that, and turns out in Vue, it's just the matter of doing Vue build. I was already doing this, besides the modern. Just put the modern flag in there, and everything happens behind the scenes. All these script type modules, generating two different bundles, putting them in index.html, everything happens behind the scenes, and that's really cool. Only unfortunate thing is in Safari, Safari downloads both files, so it's really annoying because we definitely don't want that. So there's actually a patch for it, and Vue includes that as an inline script for you. So Vue's got you covered there as well. So basically, this is a drop-in replacement for your build command, and that's what I did. I used modern build for all my Vue projects, and now I'm shipping only modern code to modern browsers, super lean, and when I need to debug some stuff in production, I don't need to deal with these horrible source maps. Just do async await, nice and clean, right? So you may think like, hey, why is this not the default? The reason it's not default is because it creates this inline script, and that means that you may have to change your content security policy, right? Because your content security policy from the backend may probably be restricting your browser to execute any inline scripts, right? So that's why they haven't made it default. It's a little bit slower as well because it has to create two builds. That's why it's also not default. And also, Vue team wants to collect all the first-hand experience from all the developers before they actually make it the default. So that's the reason why it's still behind the flag. And many people don't know this flag, and it's super awesome. I think I'm going to the next topic here, but before I do that, I also found out this really cool tool very recently to make your code even leaner, and it's called Purge CSS. I don't have it over here in my slide, but what it allows you to do is just a post CSS plugin that's going to go through all your CSS, all your Vue files, index.html, all your TypeScript, JavaScript files, and it's going to check all these CSS classes that are not used in any of those files, and it's going to clean them all up. So I was using Tailwind, the CSS, which is like a utility-driven CSS framework, right? You can basically create anything without ever writing a single line of CSS code because there are classes for everything. So that's the idea behind Tailwind, but it also has 300 kilobyte worth of JavaScript, CSS, and I used Purge CSS on it, and then it went to less than 5 kilobyte because I was using so little of it. And I just really wanted to share with you guys because I was talking to a couple of guys over there before this talk, and I was really happy to share with them, so I wanted to share with you guys as well. So now with that, the setup that I have is like super lean and mean JavaScript, and also lean and mean CSS as well, using Purge CSS. So just wanted to share with you guys. Next, Purge, so P-U-R-G-E, like the movie Purge, yeah. So next up is keep alive components. So for this, I got a demo. If everything works well, resolution, displays. All right, so keep alive components was the next thing I was gonna talk about, right? So I had this problem where I had this list of users, or a list of some kind of list, and it was infinite scrolling, right? Sort of like what you see in Facebook and Instagram. And I scroll down and it gets new list. And let's see, I'm gonna click on this last red item over here, right? I'm gonna click on it, I go to a detail view, and then I go back and I end up all the way on the top. So the user completely lost the context because that component was destroyed, a new component was created. When you go back, the old component is generated anew, right? So this was a problem I was facing. So the client was like, hey, that's kind of annoying. So user is losing the context, I'm losing the context. Can you make it better so that it actually doesn't do this? So I was like, oh, okay, how do I do that? So I need to probably lift up the state for both the components higher up and blah, blah, blah. I try to create some strategy. Turns out in Vue, you have this component called keep alive component, and whatever you pass to the keep alive component, it's going to keep it in memory. It's going to keep the virtual DOM in the memory. So later when you go back to that component, is it just instead of recreating everything from scratch, it's going to use the previous information that he has kept in the memory and use that to show that page. So with this in place, let's save it, and I'm going to reload it. So I go down, and I'm going to hit the last yellow, right? And last yellow, go back, and everything is nicely in the memory, so like no recreation of all that stuff. So that was like, that saved so much time for me, and it is such a nice, elegant solution. And obviously, I didn't want to keep everything in the memory all the time. That's not good for the memory, but that's probably not good UX either, right? So that's also taken care of by the keep alive component. You can include which component you want to actually keep in the memory and keep them alive. So in my case, the list page, the items page is kept in the memory. So whenever we go back to items page, it's going to try to reproduce what it knew before as the new state. So that was super cool. That was the fourth item. So moving on, reusable components with scope slots. So I have an example here for this thingy. So imagine you have like a users list, right? So this is a Vue component. So let me try to explain what's going on. It takes in a prop called users, which is an array, and it's required. And it's going to loop through the users and display the first name and last name of the users. And so all cool, and we're going to use that component as users list, pass in the props, users. So there's some users data somewhere, right? So this is the result. Then later somebody comes around and says like, hey, we got a new users list, and there you got to show avatar. Oh, okay, cool. So then we're going to change the component, and we added a new flag called show avatar. And in the template, we're going to add a conditional, like, hey, if show avatar is set to true, we're going to show the avatar. Then the person comes around again. Oh, by the way, yeah, so this is the new way of using the component. Show avatar is sent as true, and then you have the users list with avatar in there. So the person comes around and says like, hey, we need email as well in this list. Okay, sure. So we have another flag added, show email, another conditional in the template, show email, if show email, show the email. And we're going to use that component now using like show avatar, show email, right? But you can see that this does not scale really well, right? Like as the requirements change, and mostly the requirements are like aesthetic things, what to show, right? Not the business logic, just like gonna show this and that and there, here and there, aesthetic stuff. But the component is like full of now like flags to control things, and our template is kind of getting crazy as well with all the conditionals. So that's where scope slots come into the picture. Scope slots. So this component that we saw before, you can rewrite it in scope slots like this. So what are the differences here? We removed all the flags, like the show email, show avatar, it's all gone. And in the loop, it's pretty much back to the way it was in the very beginning. We loop through the users and show the list item. By default, we show first name and last name. But there, we give a slot. Slot is where the consumer of the component can inject its own content, right? Sort of like children in React world, or ng content in Angular world, I believe. Sort of like that, the slots. And here, the cool thing about scope slot is this scope slot is going to give user data that is coming from this loop. Each user data is going to be given back to the consumer of the component. And that's really nice. Now the consumer of the component, whoever is using the users list, can decide what to show from the user. So that the second case where we needed to show the avatar, we're just going to do, oh, just a sec. By default, this is the component usage, right? Now the person came and said, like, hey, we need avatar. Nothing needs to change in the component itself. Just in the way the component is used, we're going to use that slot. And in that slot, we're going to get the user object. And now just show the avatar, right? So the consumer of the component is now responsible, optionally responsible, to display, to determine how to display the items for this component. Now, the email thing. How do you do the email thing? No big deal, same stuff. So you have the same slot, you have the user data, just add email to it. So your component doesn't need to change. And this scope slot pattern was really, made me really happy because you can create such reusable and flexible components, especially if you're creating a component library. You have no idea how your components is going to be used later by the users of your component library, right? So in that case, you focus on the business logic. Imagine this list was like filterable or paginated or infinite scroll or whatever. All that business logic exists in the user list component, like it should, but the aesthetic part of it is optionally offloaded to the consumer of the component. So your component users can just do whatever they want to just show the component in however way they want it. You focus on the business logic. And that's what scope slots allows you to do. And I think it's such a powerful pattern. I believe in React World you can do the same thing using render props or higher order components. And for me, this pattern was very declarative and clear on what it was doing. So I really like it. And I also like to use this library called Vue promised whenever I'm working with asynchronous data in my components. So imagine there is a component. OK, this one has a lot of code, so let's try to run through. In the end, this component is getting users from some API and setting that as the data, and later it's going to loop through that data and show the users list again, right? But as a good developer, we're going to make sure that we handle the error cases and we handle the loading cases. So if there's an error, you show the error message. If the data is still being fetched, then you show is loading message, right? So, but to do that, you have this lots of control points, lots of variables, and lots of boilerplate code. Imagine the same similar kind of components throughout the application. You have the same boilerplate code everywhere. So Vue Promise uses this scope slots API to make your code really declarative. So this code gets converted into something like this. On the component side, we don't have any of those control variables. All we care about is user's promise, right? And then there is a promised component that can consume that promise. And it has 3 slots. One is pending, when we are waiting for the data. The other one is when the data actually arrives. And because of this scope slot, we actually get the data. And one is when there is an error. And because of the scope slot, we get the error. So we can display the error message the way we want it. We can display the data the way we want it. And this is really declarative. We removed all the boilerplate code. So I like to use this plugin a lot. So I would like to recommend you guys to check it out as well. It's called Vue Promised. Next up, Portal View is another, something like React Portal. You know, when you need to, when you're using tooltip or models and you have these z-index issues, you want to make sure that the tooltips and the models end up at the bottom of the body or something like that. So you don't have to battle with the z-index issues, right? So Portal View allows your component to sort of like portal out a part of its component tree somewhere else in the DOM. And it's also based on the same scope slot way of doing things. So basically, you can have a component, like a model component, and instead of trying to show the model component right where the component is defined, you can define it in the end of just right before the end of the body tag or something like that. So that's also built on top of scope slots. Very powerful API, the scope slots, so highly recommended to check it out. Last stuff I got is cranking out web components. So in this project that I was doing, I created a component, and the client asked me to, use that component, only that component, in a completely different environment. In the same way, like you can embed a specific tweet in any page, right? Like using iframes and all that. In the same way, just like, hey, give me one component that I can inject everywhere. I was happy to find out that Vue can build any component into web components. It's going to try to convert it into 100% native, but there is requirement for Vue runtime though. But the result of it is really cool. And for this one, I have a demo to demonstrate it better, I guess. So let's try to see if we can work it out. So let's say I'm going to create a component called hello world in Vue, and there's an app.vue. So I just created an app.vue component, app.vue file, right? And in here, I'm going to create a Vue component. So it kind of looks like this. What's happening here? I'm just creating a button. When you click on it, it's going to invoke the greet method. That's just going to do hello world. And it has a prop, the color of the button. By default, it's green. And it's going to try to set the color to whatever prop is given. And it also has greet as the message in the button, but it is using slots. So the user of this button component can just put whatever text they need in the button. And we have some styles as well, right? So this is the Vue component I have. Now, the really nice thing in Vue is Vue CLI is you can just serve this one single file with Vue serve, and it's just going to start up a development server, do all this transpilation, set up the live reload and everything, and give you this URL where you can easily test out a component. So if you want to just like try out Vue today, and you have never done it before, just create a Vue file, create a component, and just run Vue serve. And then you're all set, and then you can see this component in action. So that's really cool. So here, that's what it does, right? You got a green button. At least it appears green. Yeah. And then you click on it, and then you get a hello world. Cool. So imagine that you need to use this component in a React project, right? So what would I do? I would go ahead and do Vue build. And there are a bunch of options here. Target is WC web component. And I'm going to call that web component the custom element hello world. Go ahead and build that. So it created a couple of files, hello world.js and a minified version of it. And that's the web component. And with this, all the bindings between the web component layer and the Vue layer. So I have a React app setup that I started with create React app. So what am I going to do is I'm going to copy from the hello world, just hello world.js, the web component. I'm going to copy this into the public folder. And let's start up the React app. So over here, I got the hello world.js. And I'm going to add a couple of scripts. Like I told you before, it is going to need the Vue runtime, right? So I'm just going to go ahead, find out Vue from the CDN, and then use that as a source. And of course, I need the web component itself. Source equals hello world.js. And then I'm going to go to the app.js in the React source, and I'm going to use my hello world component. And with that, I should be able to just do npm start. Let's see if that demo thing is real. So we got this green button here. This is the Vue component as a web component. I click on it, and it does the thing, right? So let's check out the source code. What does it look like? So web component is all about shadow DOM, right? Here, this is the component, hello world. It creates a shadow root, and all the styles that we created is under the shadow root. So it's encapsulated using web components, shadow DOM API, and we got the button over here that's actually having the business logic. So we had a prop, right? So let's try to use the prop. Let's say we had a color over here, like color equals hot pink. Why not? And I'm just gonna use the, what did I call it? Color? Oh, I'm just gonna pass the color here. And then there we go. So you can just pass in the props from the React component in there. The only bad thing here is actually React. There's this website called Custom Elements Everywhere, created by Rob Dotson, I believe. Custom element everywhere. And this is basically a live documentation of how different frameworks are interoperable with Web Components API. And React is lacking a little bit because React, whenever you pass in props into a React component, it passes in as attributes. So even if you're passing in like complex objects, to the web component is just going to be an attribute, right? So Vue and all the other frameworks like Angular and Svelte and all that, they pass in as a property of the element as well, so you can hook into that. So if you wanted to pass in like a complex object here on React, that's not going to work. I guess React team is working on this, improving this interoperability with web components. But on the other frameworks, you know, like Angular, if you're using this web component, you can even have complex objects as props, and you can just pass into those components, and you can listen to the events the way, like in Angular world, how do you listen to an event like this, right? You can just listen to any event that is fired from the Vue component itself, just like as if you're using a native HTML element. So that's really cool. And this is the thing that I used. Oh, by the way, you can also, of course, do like set the text to hello from the React world. And see. Right, so you can use slots, you can pass in props and all that stuff. And that's what I did. I just compiled the component that needed to be in different applications as a web component, and they could just use it in different platforms, provided that they need to use the Vue runtime. So that kind of brings it to the last. Do I have a slide? Not really. Yeah, that was it. Those were 6 times. Those were the 6 times, like, you know, like Vue sort of helped me out. Like I had some issues, and there was really nice, elegant solutions for them. And since the very beginning that I've been using Vue, that is the kind of thing that keeps bringing me back to Vue, the simplicity of it. And that's what I wanted to share with you guys. And thank you very much for listening. Questions? So if you have any questions, sure. Oh, so the question is, when is Vue going to start supporting TypeScript, right? So I'm actually using TypeScript in my project right now. I'm using Nuxt, which is a framework on top of Vue. And there is this package called Nuxt Type Property Decorator that gives me all these decorators to have type safety in my application. So I'm already using that, and it works. I gotta say, it works really great. Vue itself is gonna have better TypeScript support starting Vue 3, which is, I think, if I remember correctly, is gonna come in Q2 or 3 this year. So then there's gonna be native, better support for TypeScript. But if you're on Nuxt, Nuxt Property Decorator is really great. And Nuxt Property Decorator is a combination of other packages like Vue Property Decorator, Vuex Class, Vue Class Component. So if you're just on Vue, you can also use these 3 packages to really have well-built type safety in your application. Yeah. All right. Anybody else? Yeah, sure. No, so Vue.js source code is something that you need to add by yourself as one layer on top. And they're just going to reuse. All these different components that you have is just going to reuse the same Vue runtime. Yeah. You had a question?
Regarding the dynamic imports, so you don't need to add any additional script tag, right?
No, you don't need to add it.
Dynamic import in the script itself, and then it will automatically load.
Yeah, that's right. Yeah, that's right. So, so the advantage of dynamic import is you can even dynamically generate what you're trying to import, right? So let's say that, let me think of an example. I cannot think of an example right now, but let's say there is like a theme, like red theme, blue theme, pink theme, or whatever in your source code. You can dynamically import that variable. You can dynamically import a string that is constructed using /theme and then a variable. You know what I mean? So when that happens, what Webpack does is so in Webpack, everything is static. There's nothing dynamic in Webpack. So how does this dynamic import work in Webpack? So when Webpack builds this and sees like, hey, there is a dynamic import, but it's using a variable, it's going to create separate chunks for everything that exists within the theme directory, right? So whenever in the runtime we're trying to import that specific file, there is a chunk available for it. So that's how it works. And for the rest, you don't need to do anything else. Yeah.
One more question.
Yeah.
Usually, well, we normally they use Axios, but I guess this is another framework.
Oh, so Vue Promise does not really care about how you get the data. So it can consume any promise, any denable. So you can use Axios, you can use Fetch API. As long as it's giving you the promise, it can wait on it. As long as it has .then property, it can wait on it. So that is not its concern, so to say. Yeah. And Vue Promise also has this, like, there may be a situation where, let's say, let me show an example. So there is this is something that is built on Vue as well. So you can get different kinds of data for different subreddits. And shameless plug, by the way, I've created this Chrome extension. It's on my GitHub. Maybe you guys can contribute and help make it better. But I just wanted to go, like, whenever I go to a new tab, I wanted to get a highlight of, hey, what's new, what's in JavaScript world, kind of thing. So imagine a situation where you refresh this. But as you can see now, when I refreshed it, only the loading was shown, but the data was gone, right? So, because there may be a use case where you keep showing the data, but load something in the background, so you just have loading on the top, but you want to keep showing this. A combination of two different slots, loading slot and a data slot. You can do that as well in Vue Promise, so that's really cool as well. So you can combine multiple slots. That's really powerful as well. All right? All right, then thank you very much, guys.
For again a nice talk.
My pleasure.
Third time, but I think the best time. So we got a little present for you.
Oh, that's
Hope you
great.
like it.
Yeah, for sure.
Craft beer, the best Rotterdam beer of the world.
Oh, really?
So it's from here.
Cool.
Hope you like it.
Let me get rid of this. Thank you very much. I appreciate it. Thanks a lot.